Hey everybody, this is a video for my applied grade 11 students. This is the last few pages in the chapter 3 booklet. And I don't have any new formulas to show you today. It's still sine law and cosine law. But now we're going to use those two laws to solve some problems where we don't know ahead of time which law we're going to use. So before we start, let's make ourselves a little study sheet here of which formula to use when. So, this isn't going to work. Hold on. There we go. That'll work. So, where's my pen? Oh, there it is. Oh, we're off to a great start here. So when do I use the sine law? Well, first of all, both of these things are what I would say for oblique triangles. That's a triangle symbol. They're for oblique triangles, right? Obviously, if I have a right triangle, I'm just going to go back to grade 10 and use SOHCAHTOA. So when I don't have a right angle, I have to use either sine law or cosine law. What is sine law? Well, the two formulas are A over sine A equals B over sine B equals C over sine C. And that's the one I use when I'm looking for a side. But if I'm looking for an angle, I flip it over. So I'll say or sine A over A equals sine B over B equals sine C over C. So there's the formula. When do I use it? I use it given a triangle with an angle and its opposite side. So that's three situations. I could have a situation like this, where I know this angle and the side across from it. And there's usually somebody who goes, well, what if it's the angle on the right? Well, then just imagine flipping the triangle over in your head, right? It's still the same triangle. But I give the angle and that side, and then I know, for example, say, another side. This is the one that makes people giggle. That's angle, side, side. What if I know this angle and this side, and I know another angle? We call that one angle, angle side. Those are actually the two easiest ones. This one's harder. I'll do this one in blue. This one's angle, side, angle. And that's where I'm given two angles and the side between them. Why is that one kind of one step harder? What do I have to do first before I can do sine law when I'm doing that? Anybody remember? You have to find this guy by using the 180 rule. Then I know an angle across from a side and I'm ready to do sine law. But all three of those situations are sine law. But that's not the only situations we can have. Our other law is the cosine law, which when I'm looking for a side looks like this. And when I'm looking for an angle, is a little more confusing looking. It's a big rational expression. Or. And I won't bother writing it in words, I'll just show you with the pictures. I use this formula to find a side if I'm given side, angle, side. Hopefully everybody realizes why you can't use sine law there. There's no way I would figure out a side opposite an angle just using my 180 trick. And the other one is, what if I'm just given all three sides? Side, side, side. So there it is. That's when I use cosine law and sine law. So there's just kind of a little quick, like a study sheet. All right. Now, to find the measure of missing angles and sides, we can use sine law or cosine law. Of course, if you have a right triangle when you're solving problems, you just go back to SOHCAHTOA and Pythagoras. So let's start with this example here. Oh, isn't that nice? They don't give me a picture. A tower is supported by two guy wires attached to the top of the tower and fixed to the ground on opposite sides of the tower, 27 meters apart. So I'm going to draw a tower. Put it in blue. There. It's a very skinny tower. The tower is supported by two guy wires attached to the top, and they're affixed to the ground, and they are 27 meters apart. One wire makes an angle of 53 degrees with the ground. The other wire makes an angle of 62 degrees to the ground. And there's my picture. I'll make a question like this worth like 4 marks or 3 marks, and one of those marks, or at least a half of one of those marks, is just putting the picture down and labeling it properly. Now, it didn't tell me anything else. Determine the height of the tower. I would like to know how tall this tower is. There's people who might go, oh, wait a minute, we're going to assume it's not the Leaning Tower of Pisa, so it's got a right angle to the ground. You're right, it does have a right angle to the ground. So can I use SOHCAHTOA? Not yet. Question? Excellent question. The question is, which side do I put the angles? Does it matter that I put the 62 over here or the 53 there? No. It just means we're standing on the other side of the tower looking at it from the other way. It's the same tower, same picture. So good question. No. Doesn't matter. All right, can I use SOHCAHTOA right now? No. Somebody usually says, well, you could cut this 27 in half. Oh, it wouldn't be right in the middle because that's not an isosceles triangle. That's not going to be right in the middle. I have no choice. I have to use either sine law or cosine law. And which one do I use when I'm given 2 angles? It's got to be sine law. So the first step is I need to know an angle across from a side. So I'm going to call this one angle A, which means that that's side A. I guess I'll call this B, which means that's side B. And this is C, which makes that side C. So the first thing I'm going to solve for is angle A. Angle A is 180 degrees minus 53 plus 62. And then I'm going to figure that out. 65 degrees. So that's how big this angle is all the way across here, 65. Now, I actually have choices here. All I need to solve for the right triangle is an angle and a side. I could have this side here, side C, and solve this triangle for the height. Or I could solve this B and that triangle for the height. It really wouldn't matter which one I picked. I know them both. So I'll go with B. So I'm going to solve for side B. So if I'm solving for a side, and I know an angle across from a side, I'm going to use the sine law. And I have to use these 2 ratios because A and side A are the 2 pair that I know. So B is what I'm looking for. I know angle B over here, 53 degrees. A is 27. And the sine of A is the sine of 65. Now I do the algebra step. I cross and multiply. So sine of 53 times 27 all over sine 65. And then we punch buttons. There we go. Oops. Hang on. First we move this up a bit. Then we go and we punch buttons. Come on, calculator. There you are. Clear, 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 clear. First, always check to make sure you're in degrees. We are. Okay, so here's my calculator. Sine of 53, I got to close that bracket, times 27, divide by sine of 65 equals. So side B is 23.79. I'll just round it there. Meters. But that's not what I wanted to solve for. What did I want? Oh yeah, I want the height of this triangle. So can you kind of see, let me go to a highlighter. Can you kind of see that this triangle here is its own right triangle, and this triangle here is its own right triangle. And I got to tell you, I actually don't know enough about the yellow one to solve it, but I do know enough about the pink one. So I'm going to solve for this pink triangle here. In that pink triangle, this height is opposite 62, and this b that I just found, right, this b is 23.79. That's a hypotenuse. So which one is opposite hypotenuse? Sine. Sine of 62 is opposite over hypotenuse. And so that I don't lose accuracy, you're going to notice I'm not punching in 0.79 on the calculator. I'm going to use my answer button. First, let me rearrange this. D for denominator, or sorry, T for top, T for times, sorry. So 23.79 times the sine of 62. And I actually didn't erase my number, but on this kind of calculator, even if I did erase it, so I cleared it, oh no, I lost my number, it remembers it, right? It knows the answer. So I can go to the calculator, and I can go second function, and there's answer right there. I don't know if you can see that on the screen. Answer times the sine of 62 equals, and let's see, where does it round? Determine the height. Doesn't say where, so I'll just round it. I'll just round it to the nearest meter since it's 0, 0. Height is 21 meters. 21-meter tower. All right, so there's our first word problem. That one was a sine law. Here's another kind of problem that you'll see a lot of. One of these guys here, where you stick two triangles together, and you need to figure out something in one triangle to solve the other. Determine the length of AC. So we're looking for this line here. So actually, I'm going to call this, the thing I'm looking for, I'm going to call it little b, right? Because it's across from angle B. Now, the problem, I know that there's an angle B, or there's a side B in the other triangle, but for now, I'm just going to call that B. Now, what do I need to know in this triangle? Right now, I don't have enough to solve it. I don't know any sides. But if I find this side, can you see where I'm highlighting there? If I can find that side, that's the same side in the two triangles, in both triangles. So I'm going to find that side, which I guess I'd call little d. So little d, I'm going to switch to black so it's easier to see. Little d over the sine of d equals, and I've got the same problem I had in the last problem. I don't know this angle up here at C when I know side C. So I guess the first calculation I should do, I'll do it over here, is that angle C in this triangle, you know what? Which angle C do we mean? Why don't I use three letters? We'll use the three-letter system this time. Angle DCB is 180 minus 45 plus 55, which is 80 degrees. So little d over sine of angle D, there's no doubt as to which one is angle D, is going to be the side I called little c over the sine of, I guess I'll call it DCB, right? The angle here that I just figured out is 80 degrees. Let's put in the numbers. D over the sine of 45 is equal to 50 over the sine of the angle I just found, 80. And doing my algebra step, this crosses and multiplies. And I'll save you watching me punch buttons again, since this is just the exact same as the last button punch sequence. I got a number. It is 41.6. Okay, but again, that wasn't the answer. All I know right now is this blue line. That blue line is part of the other triangle. And oh, what does this little symbol mean again? It's a right triangle. So that gets me back to SOHCAHTOA. So if I know this line, which the blue one here, and I'm looking for this, I'll make it red line, but I'm given this angle, what are those two sides? This one's an opposite. This one here is an adjacent. Which one's opposite adjacent? Tangent problem. The tangent of 66 is the opposite, which is what I'm looking for, the B, over the adjacent, which I just found, 41.6. T for top, T for times. And then from there, B is 93.4. Again, I'll save you watching me punch buttons. Feel free to run through that yourself. That's the answer I want, because that's the length from A to C. You could, it's a word problem, you might want to go, therefore, AC is 93.4 meters. All right. Oh, you know what? I guess I did lie a little bit earlier when I said there's no more new things to learn. We're just applying it to problems. If you didn't learn this in grade 10, it might be news to you now. Do you remember these words from grade 10? Angle of elevation is how much you have to look upward to see something when you're an observer. So elevation means look up. Angle of depression, like the word kind of implies, when you're depressed, you're down. So you look down to see something. This is your eyeball. So your eyeball's right here. Here's a sideways eyeball. There we go. It's got nice lashes. They worked hard on their eyes. Look at that. A little bit of shadow. Very nice. And this person over here is looking from here. And this will be black eyeshadow. This person's a little more goth. There we go. Very goth. There we go. Okay, so there we go. And this person's looking. If they look straight ahead, they'd look over the object. They have to look down to see it. That's an angle of depression. So, here is the problem. A bird is sitting at the top of a tree, spots two worms on the ground, one to the left and one to the right. So here's the bird. The bird is very round. And he's looking to the left, he's looking to the right. We're going to assume that the tree grows straight out of the ground. So here's B for bird. I'll put that as B for bird. And we'll call the worm worm A and worm C, because why not? And what do we know? We know that the bird, if he looked straight, he wouldn't see either of the worms. He has to look down at an angle of depression of 60 degrees to see the first worm that I put at A. There's the worm. There we go. Drew some more. I guess I'll draw a bird too. There we go. Bird. There, bird. Okay, so we've got an angle of depression of 60, and we actually somehow know this bird somehow knows how to judge distances. Super bird. 5.5 meters away. The other worm is 4 meters away, and the bird has to look down at an angle of depression of 50 degrees. Well, this is a dilly of a pickle. I don't know any of the angles in my triangle. Well, actually, yes, I do. Because we're going to assume two things. We're going to assume that the ground is horizontal. It even says, what is the horizontal distance? So I guess that's not really an assumption. It's telling us the ground's horizontal. It's a flat ground. And we're going to assume you remember Unit 2, or Chapter 2. What can I do here? Supplementary. Ooh, supplementary is not quite the right one. Interior alternate. If this is parallel to that, look at this. That's a right angle, because, again, the tree grows straight out of the ground. And if that's 60 degrees, this is 60 degrees. Because Z rule, interior alternate angles. I'm going to get rid of that. That's cluttering up my diagram. Okay? Oh, and while I'm at it, backwards Z rule. What do I know about angle C? It's also 50 degrees. Now I can use the 180 rule to figure out the angle at B. So angle B is 150 minus 60 plus 50, which is 70 degrees. And this is usually where somebody says, you know what, Mr. K, I couldn't remember interior alternates, but didn't I kind of know that all three of the angles up here had to add to 180? And you're right. But notice that would have been the exact same calculation.
Then
Well, that's fine if you want to think about it that way, but I liked using my interior alternates. I like the Z rule. Okay, anyway. Either way, as long as we all agree that this angle underneath the bird's butt is 50 degrees, we're ready to, or sorry, 70 degrees, then we're ready to solve the problem. So the problem is once again going to be sine law, because I want to know the distance between them, which I'm going to call side B. C is this one, A is that one. And again, it doesn't matter which side I use, I'll use A this time. So B over the sine of B equals A over the sine of A. So B over the sine of we just figured it out, 70, equals A, which is 4, over the sine of A, which is this 60. And then do my algebra step, cross and multiply. If you're getting really comfortable with these and you just want to jump to the answer from there, I'm okay with that. Okay, and then I punch buttons, and again, I'll save you watching me punch buttons. Because, let's see, do I have this right? 5.6? I think it's 5.6. You know what, I better double check. So 70 sine times 4 divided by 60 sine equals, oh, hang on a sec, something's gone wrong. Sine of 70, 4.3, oh, did I punch buttons wrong? Oh, I'm in radians on my calc, oh, I grabbed the other calc. You know what, I'll go back to this calculator. I'm in radians on my other calculator, there we go. Okay, so, clear. Helps if you turn it on. On, there we go, clear. Sine of 70, close my brackets, times 4 divided by sine of 60. Close brackets equals 4.34 is the answer I'm getting. And does it say we're at around? Nope, then we don't care. And are we in meters? Yes, we are. We're in meters. So there we go. Next, Jeff decides that it would be fun to launch a firework. He sets the firework on the ground at position 0, follows the path outlined. I don't know why the firework suddenly changed direction like that. It must have hit somebody. This guy's a psycho. He aimed the firework at somebody and bounced it off of them. All right. So, if I'm calling the point where he rocketed the firework off somebody H, and my goal is to find out the distance from where it started to where it ended, I'm actually looking for little h. That's how long that line is. And from there, I also want to know, let's see, what else? It says, if the firework lands at position L, how far away from its starting point? Okay, and this time, ooh, look out, this time it tells us to round to one place. And okay, if that's little h, this is, I guess this is already labeled, that's a little o, and this is little l. And I think I'm ready to do this one straight up. This is, again, a similar type of problem. It's angle side side. So this one I can do, I think, pretty much straightforward. Oh, no, I don't, because I don't know angle h. So here's what I'm going to do. I'm going to find angle L, use it to find angle h, then use that to find side h. That's my plan. So let's find angle L. Sine of L over L, and I know O over O. So the sine of angle L over little l, which is 4, is equal to the sine of, I know angle O is 45, and they tell me side O is 6.5. So the sine of angle L is 4 times the sine of 45 over 6.5. So this one I got to do an inverse sine, right? So I punched this and got the decimal. And the decimal I got, where are you decimal I got? The decimal I got was 0.435 and change. 0.435, blah, blah, blah. So angle L is the inverse sine of that. Maybe I actually will punch this just to remind you how that looks on your calculator. Move that over. Move over you. There we go. Clear. 4 times the sine of 45, close brackets, divided by 6.5 equals 0.435. inverse sine of my answer. And there we go. 25.8 is my answer. And then from there, I have to figure out side h. So I'm going to have to find h as an angle. So h is 180 degrees minus 45 plus 25.8. I don't think you need to see me punch that on my calculator. And I got 109.2. This might be one of the first times our triangle turns out obtuse. All of chapter 4 is about obtuse triangles. And now I can solve for h by flipping the formula over and using h over h and o over sine of o. So h over the sine of the angle I just found, 109.2, equals 6.5 over the sine of 45. Cross and multiply. I'll just skip that step for now and just punch buttons. So it's sine of 109.2 times 6.5 divided by sine 45. I got 8.7 meters. Okay, there's one last example that I think you can try yourself. Okay, some people want me to slow down because I've gone pretty fast, but I'll stop the video there. You can try the last example for yourself. It's another sine law, I'll tell you that. You might be thinking, hey, how come we didn't have any cosine law? Well, you know what? There's actually, if you wanted to, you could have found this angle here and used side angle side cosine law. I'll leave that to you. See if you get the same answer. You should, if you did that one by cosine law. And I'll also leave example number 10 for you to try. I'll tell you right now, here you go. Hint, the final answer should be that angle A, right here, I'm calling that angle A, is 41.5 degrees. So give it a try and see if you get the right answer. Here, I'll move this back for the people who are still copying this out. And that's problem solving.